Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important electromagnetic theory question, that is from boundary conditions in the linear dielectrics. Already we discussed electrostatic boundary condition, one question we are discussing in the previously. Now we are going to discuss about the boundary conditions in linear dielectric material, right? So once you have to see when this question is asked, why this question is we are learning, that is also very important. Once you have to try to understand this question, first you read this question thoroughly. This question was asked in June 2016. CSIR people are asking this question, that is belongs to the boundary conditions at dielectric interface. So the off space region is there. So that is the off space region when x is greater than 0. When x is greater than 0, this is off space region, and another off space region is there, that is x is less than 0, are filled with a dielectric media of dielectric constant. This is epsilon 1 is the dielectric constant. This one is epsilon 2 is another dielectric constant respectively. So there is a uniform dielectric electric field in each part. The right of the electric field makes an angle theta 1. The left part, the electric field makes an angle theta 2. So at the interface, this is the interface of the dielectric medium. So the corresponding angle theta 2 in the left of satisfies. So how it is satisfying this one, they are asking the question. First you have to see, so this electric field is a vector, it resolves into two components. One is vertical component. So what is that vertical component? This vertical component is E1 sin theta. So this vertical component is E1 sin theta 1, right? So the same way, this is vertical component you have to take. So that one is E2 sin theta 2. So these are the vertical components. This one is E1 sin theta 1. So this one is so E2 sin theta 2. So these are the vertical components. So there is a adjacent component of this. So what is that adjacent components? Once you have to take, so that adjacent component is E1 cos theta 1. So that is the E1 cos theta 1. So this one is E2 cos theta 2, right? So these are the things we have to write it is. Now you are able to take, this is the electric field, it is going to in this direction. So the normal component of the electric field, so what is the normal component of the electric field? So the normal component of the electric field is equal to, what is this? This is the normal component of the electric field of this interface. So at the same time, the tangential component is E1 sin theta 1 is the tangential component of the electric field, is the tangential component. Now you have to take a boundary conditions. We know the boundary conditions of the dielectrics. The first boundary condition is the normal component of E1 minus the normal component of D2 is equal to 0 at the interface of the dielectric constant. So what is this one? You have to write epsilon 1 E1 cos theta 1 is equal to epsilon 2 E2 cos theta 2. So this is the equation number 1 you have to write based on that. The second boundary condition is so the tangential component of electric field. So the tangential component of electric field minus the tangential component of 2 is equal to 0. So therefore what we have to write here, so E1 sin theta 1 is equal to E2 sin theta 2. This is the equation number 2. This is the tangential component. Now you have to write equation number 2 is divided by equation number 1. You have to write it is. So what is your equation number 2? Your equation number 2 is E1 sin theta 1 is divided by epsilon 1 E1 cos theta 1, which is equal to E2 sin theta 2 is divided by epsilon 2 E2 cos theta 2, epsilon 2 E2 cos theta 2. So therefore E1, E1, E2, E2 get cancelled. So tan theta 1 is divided by epsilon 1 is equal to tan theta 2 is divided by epsilon 2. So therefore epsilon 1, so therefore we have to write it is epsilon 1 tan theta 2 is equal to, we have to write epsilon 2 into tan theta 1. So this condition is satisfied. This condition is also called as is similar to the Snell's law in optics, is similar to Snell's law in optics. So this Snell's law we also call it as a law of refraction, law of refraction, law of refraction of electrostatic forces of lines, electrostatic forces of lines. So this is the very important one. The electrostatic forces of lines can satisfy the law of refraction. Which answer is correct? So the sin theta epsilon 1 tan theta 2 is equal to epsilon 2 tan theta 1. So that is the correct option. Like this we have to do in our competitive examination. Clear? Now you able to see, we are informing you. We started the CSIR and GATE physics online coaching in our app. That app is Quantum Online Academy app. So our app symbol is like this. Once you go to the Play Store of your Android mobile phone and you enter the Quantum Online Academy, app will come. So that install it and later you have to log in it, and then you able to call. This is my mobile number 9908437460. If you have any doubt you should ask me. The courses will appear like this: CSIR and GATE physics course, and JL and DL physics course, like this it will appear, and the mathematical methods of physics. So individual papers also you able to get. This mathematical methods of physics completed now, right? Fully recorded classes are available. If you want to take, you have to take. Not only mathematical methods of physics, the classical mechanics also completed. This full paper also is available. If you want to take, you have to take. Now we started the electromagnetic theory. So electromagnetic theory every day, at least one class I have to take to you. So in between 6 a.m. to 8 a.m., in between 6 a.m. to 8 a.m. I will take the class. So daily in app. So sometimes I have to take the class in the evening also, but this is too much of art is there, that's why I am not taking. So morning definitely I have to take the class, that is electromagnetic theory. In electromagnetic theory also the first part electrostatics is completed. Electrostatics. In app also is completed electrostatistics. In YouTube also I discussed all the questions in electrostatistics according to your syllabus. Actually according to your syllabus, electrostatics, Gauss law and its applications, and later so Laplace equation and Poisson equation and boundary value problems are there. Only this much of syllabus is quoted. But even though I detailedly explained the electrostatics, what are the things are there inside, all things I told you. So utilize this chance. Once you have to download our app, you able to see the classes also. Maybe sometime so it won't open, but you able to see, sir, what is teaching in that app, you able to see. Clear? So please share and subscribe our YouTube channel. Like these videos, I will upload in our YouTube channel. Thank you so much.